In this video, we will look at vector algebra. So first, we look at what is scalar and what is vector. So the definition of scalar and vector. So let's say first definition. Let's look at the definition of scalar. So a mathematical quantity that is completely specified by its magnitude and has no direction. So in scalar ataupun dalam bahasa Malaysia kita panggil skala. Skala adalah unit dalam kuantiti dalam matematik di mana dia hanya ada magnitude. Magnitude tu kat sini kita boleh katakan sebagai jarak tanpa arah. So let's say example, if we say that we drive 10 km. So maksudnya kita drive 10 km, we are talking about the total distance we have traveled. Kita cuma cakap distance saja. Distance kita adalah 10 km. So benda ni kita panggil sebagai skala. Ataupun dalam English, we are known as scalar. So scalar variables will be denoted sebab dia tak bagi tahu arah, cuma 10 km saja. So this 10 km is referred as the magnitude. Dia hanya ada magnitude tanpa arah. So if we look at the definition of vector, a mathematical quantity that has both magnitude and direction. So vector ni dia ada magnitude dan arah. Maksudnya dia ada jarak dan arah. For example, if we say that we drive 10 km to the south. So 10 km is the magnitude, south is the direction. Then we are talking about the vector quantity. So in vector, we must have magnitude. Kita mesti ada magnitude and direction. Dia ada arah. So kat sini kita kena ingatlah. Kita ada untuk magnitude, dia ada untuk vector, dia ada magnitude and direction. Whereas for scalar, we only have magnitude. Kita cuma ada magnitude saja tanpa arah. So this is the definition for scalar and vector. Next, a unit vector is a vector that has a magnitude of 1. Maksudnya unit vector ni, maksud jarak dia adalah 1, magnitude of 1. A negative vector indicate that it change the direction of the vector. So bila kita tukar arah, kita kena letak negatif kat sini. Sekali lagi, bila kita tukar arah, kita kena letak negatif. So the vector notation, sometimes dia guna A ke B ke, dengan atas ada anak panah. So we can use A or AB, it's up to you lah. But we need to put an arrow on the top of the alphabet. Let's say AB, and then we put an arrow on the top of the alphabet, above the alphabet. So this arrow means that we are dealing with vector. Kita sedang tengok pasal vector. For example, what is negative vector? Tadi kita sebut negative vector. Let's say from A to B. So this is the arrow from A to B. Jika kita terbalikkan dia, sama ada kita tulis negative AB or we can write as B to A. Yang ni tak payah letak negatif lah. From B to A. Ataupun we can put as negative AB. So kat sini kita perasan, bila kita tukar arah, kita kena tambah negatif kat depan. Sekali lagi, bila kita tukar arah from A to B, kita tukar arah B to A, we need to put a negative in front of this one. Negative AB. Or you can write as positive B to A. Ataupun kita boleh letak macam ni, B to A. Cuma biasa kita tengok kat sini. For example, from A to C, let's say, the vector of A to C. So alternatively, we can move from A to B dulu. Kita bergerak daripada A ke B. Kemudian B ke C. Macam alternatif lah. A to C, we can move from A to B dulu. Kemudian daripada B to C. So vector of AB actually is equals to from A to B, daripada A ke B dulu, plus kemudian daripada B to C. B to C. So where A to B, di mana A to B, vektor dia adalah U. Plus, whereas from B to C, the vector is V. So, this is how we do it. Mungkin kenapa so tak boleh A to C terus? Sebab kat sini unit dia bagi A to B, B to C. A to B adalah U, B to C adalah V. Daripada A to C directly, dia tak ada unit diberi. Sebenarnya dia adalah U tambah V. Vector U plus vector V. Let's say we look at this case. We want to find, case ini we want to find the vector of PQ. Kita nak cari vector PQ. In order to find the vector PQ from P to Q, what we do have to do is kita kena bergerak daripada P to O dulu. Kita terbalik P to O dulu. Kemudian baru O ke Q. We need to move from P to O, P to O, plus, and then from O to Q, O to Q. So, you boleh perhatikan, from this one given U ni, vector U ni adalah daripada O to P. Tapi kali ni kita nak P to O. Kita terbalikkan dia. When you move in the opposite direction, you need to put a negative here. So, that's why dia ada negative kat sini. Negative vector U plus vector V. So, kat sini you kena ingat lah. When we change the direction, you have to put a negative. Bila kita ubah arah dia, sebab daripada O to P, dia punya vektor adalah positive U. Tapi sekarang kita nak daripada P to Q. If we want to move from P to Q, first we need to move P to O dulu. And then baru O ke Q. That's why bila kita tukar arah, we need to put a negative. That's why sini ada negative vector U plus vector V. Then next we look at vector in 2 and 3 dimensional space. So this one is for 2 dimension, dua dimensi lah. Vector and Cartesian coordinate system. So the vector V shown above is a 2-dimensional vector drawn on X dan Y plane. So ini adalah 2D. What we know is 2D. Kita cuma ada paksi X, paksi Y. The vector V is moving in 2 different direction. Dia ada 2 direction simultaneously. Di mana adalah 6 unit to the right. So this is right, Dia bergerak 6 unit to the right. You can see from here, 6 unit. 1, 2, 3, 4, 5, and 6. So here is 6 units to the right. So untuk X axis, we are using the unit I. Kita akan guna I. Whereas for Y, we are using J. So 6 unit to the right. And here is 3 unit in the up direction. Kemudian, dia bergerak ke atas sebanyak 3 unit. So 3 units. Bergerak ke kanan 6 unit, move to the right for 6 unit, and move in the up direction for 3 unit. So V, the vector V ni, we can write as 6I plus 3J. This is moving to the right and up. How about moving to the left? Jika left and down, jika left and down, let's say the same question, we have to put negative 6I minus 3J. If left, we have to put a negative. If down, also we have to put negative. Kita kena letak negative lah. Right and up, we put positive. But if left and down, we need to put a negative. Kan Jika left and up, positive. 6I plus 3J. I is to the left. to the right. I ni adalah paksi X. J ni adalah paksi Y. I is refer to the X-axis. If it is moved to the right, maka dia positif. Jika dia move to the left, then we have to put a negative. Whereas for J, the unit J, we are referring to the Y-axis. If moving upward, then it's a positive. If moving downward, then it is a negative. How about 3 dimension? Now, next we look at the 3-dimensional vector in 3 dimensions. So, vector on scalar Cartesian coordinate system. The vector OP has initial point at the origin 0. So, vector P ni, OP ni, originally dia kat sini. This one this point. And terminal point at the end of the point lah. P, the coordinate of P is 2, 3, and 5. 2 is referred to the x-axis, 3 is referred to the y-axis, and Z ni refer to the 5 is referred to the 5 is referred to the z-axis. So the unit that we're going to use is I, J, and K. Kita akan guna I, J, K. We can draw on OP as follow. That's why vector of OP in 3-dimensional is 2I plus 3J plus 5K. Just ikut koordinat kat sini je. Depan I, tengah ni J, belakang ni K. So I, J, and K. So this is the coordinate. 2 unit, 3 unit, and 5 unit. Next, we look at the basic operation. The operation in vector. Just like a matrix, sum of vector U plus V. Let's say if you have unit U1, U2, V1, V2. So, bila kita tambah, kena ikut susunan lah. U1 plus V1. Yang depan tambah dengan yang depan. Yang belakang tambah dengan yang belakang. Dia macam koordinat. Paksi X, paksi Y. Coordinate of X, coordinate of Y. X tambah X, Y tambah Y. Depan tambah yang depan. Yang ni Depan tambah yang depan. Belakang tambah yang belakang. So, different of vector. Maksudnya kita nak minus. Sama je lah. Depan tolak depan. Belakang tolak yang belakang. Scalar multiplication. So, K times vector U. Dua-dua kena darab You have to remember. Jangan darab depan saja. Dua-dua kena darab. Same operation hold for vector in 3 dimensions. Sama saja. Jika dia ada X, Y, let's say dia ada I, J, and K. Sama saja. Tambah, tambah. Tolak pun tolak, darab pun sama. So this one we just, for basic operation, we just look at sum of vector, difference of vector, and scalar multiplication. This one is scalar multiplication. Okay, right. Equality of vectors. What means that equality of two vectors? Two vectors are equal. Dua vektor ni adalah sama when they have the same magnitude. Dia ada jarak yang sama dan direction yang sama. Arah yang sama, jarak sama. In the diagram below, vector A is equals to vector V. Vector A is equals to vector B since they have the same magnitude and direction. So A ni sama dengan B. Sebab dia punya jarak sama, arah pun sama. So next we look at the magnitude of the vector. Magnitude of the vector. Yang ni kita dah familiar dah dia punya formula. Let's vector U is U1 and U2 which is equals to U1I plus U2J. Dia boleh dalam dua bentuk lah. U ni contoh Vector U kita ada let's say 3 and 4. Or I can write in the form of 3I plus 4J. So the magnitude of U. Jika magnitude, kita letak simbol yang ni. Formula dia adalah square root of. Dua unit ni kita kuasa duakan dia. 3 squared plus 4 squared. Jangan ambil I and J. Without the I and J. So this one is square root of 9 plus 16. So here we have square root of 25. And then is 5. This is how we calculate the magnitude. Let's say vector V. We have, let's say, I plus 3j minus 2k, for example. So the magnitude of V, magnitude untuk V ni adalah equal to square root of I, this one, the coefficient means that is 1. Tanpa guna yang I ni jangan ambil plus 3 squared minus 2 means that plus negative 2 squared. So yang ni saya boleh letak dalam coordinate means that is 1, 3 and negative 2. So here I should have square root of 1 squared is 1. 3 squared is 9. 2 negative 2 squared. Make sure that bila you tekan calculator, kena letak kurungan. Bila kuasa 2, maksudnya dia akan jadi positive 4. Jangan tengok plus minus or negative. This is the common mistake made by the student when they say that, when they see that positive, or here is positive, negative. So positive, negative, here is minus. Salah So kita kena kuasa 2 kan dulu. Negative 2 kuasa 2, positive 4. If you want to use calculator, make sure that you put a bracket. Jika you nak guna calculator, pastikan you letak kurungan. Sebab kuasa genap, kita akan dapat positive. So here is square root of 14. So square root of 14 cannot be simplified, so I let the answer in square root of 14. This is how we going to find the magnitude. For example, this one. Given that vector P is negative 2i plus j plus 5k, find the magnitude of P. So how are we going to find the magnitude of P? We just put a magnitude. This is a symbol of magnitude. Then square root of negative 1. So based on this one, our coordinate is negative 2, 1, and 5. So we just take the unit. We just take the coefficient. Kita ambil nilai dia saja. Negative 2 kuasa 2 plus 1 squared plus 5 squared. So from here, we get square root of 30. Let's say we look at exercise 1. Given vector A and vector B with the coordinate, find the vector of AB. So macam mana kita nak cari AB? The easiest way, let's say we have titik A, 3, 4, and 7. This one is just a I just sketch for this coordinate. Saya sketch saja, tak tepat dia. Actually, this one is 3D in 3 dimension. If I want to find A to B, let's say we have a point 0 here. Kita nak cari kita nak cari vector of A to B. Where the given point is this one. Dia punya point semua start pada kosong. If you want to find from A to B, katakan kita nak cari vector AB. What we need to do is from A to O dulu. And then baru O to B. Sebab all the coordinate is based on O. Sebab semua punya coordinate kita start pada kosong ni. So kosong hingga A ni adalah 3, 4 and 7. P, 0 to B is 2, negative 1 and 3. But if I want to find AB, so what I need to know is AB is equals to AO plus OB. Now I make the direction of AO is opposite to OB. So direction AO ni adalah bertentangan dengan OA. So what we have to do is we need to put a negative. For the coordinate of A ni kita kena letak negative. 3, 4 and 7. You mungkin tanya kenapa? Sebab kita terbalikkan arah dia. Yang dia bagi ni adalah OA. Yang dia bagi ni adalah OB. So when we make the kita bagi dia negative opposite direction. kita terbalikkan dia punya arah. So, ini yang dah beri OA. Sekarang kita nak AO. So, therefore, we need to put a negative. Plus OB. You naik OB? OB tak payah ubah lah sebab kita ikut arah dia. So, this is 2, negative 1 and 3. So, from here, I should have negative 3, negative 4 and negative 7. Plus 2, negative 1 and 3. So when I sum up this vector, negative 3 plus 2 is negative 1. Negative 4 plus negative 1, negative 5. Negative 7 plus 3 is negative 4. So this is the vector of AB. Finally, I can find the magnitude of AB. Again, the formula is square root of this unit, x1 squared plus negative 5 squared plus negative 4 squared. From here, I should have 1 plus 25 plus 16. So 1 plus 25 plus 16. 1 plus 25 plus 16. We should have square root of 42. So this is the magnitude of AB. Unit vector. So how are we going to find the unit vector? This is unit vector of U is U, the vector of U divided by the magnitude. This vector U divided by the magnitude of vector U. Macam mana nak cari magnitude? Macam atas tadi. Inilah cara kita cari magnitude. Let's say yang ni. Find the unit vector of vector Q. If vector Q is 1, negative 3 and I. So kat sini saya tukar jadi unit lah. I minus 3J plus K. Divide by the magnitude. This is cara kita cari magnitude. So daripada sini, square root of 11. And then pecah jadi 3. Pecah jadi 3. So if you look at this example 2. Find the unit vector of this one. Dia nak minta unit vector yang ni. If A and B is given as this one. So first we need to find 2A minus B dulu. So pertama sekali, dia nak cari unit vector of this unit. So kita kena cari 2A minus B dululah. So what is our 2A minus B? So 2A minus vector B will be equals to 2, 1 times 1 negative 1 and 2 minus B. B is negative 1. Saya tukar jadi koordinat Comma 2. K kita 2. So 2. Tukar jadi bentuk yang sama. So from here, expand dulu. So we have 2, negative 2 and 4. Darab dulu. And then minus negative 1, 2 and 2. So this one, 2 minus negative 1. Be careful with your calculation. The first one is 3. Negative 2 minus 2. Not 0, This is negative 4. Finally, 4 minus 2 is 2. So this is the coordinate for 2A minus B. Ini adalah coordinate untuk 2A minus B. So barulah kita cari unit vector. Dapatkan dulu yang ni, baru cari unit vector. So sini saya boleh tukar sebagai 3. Wait for this one. Sini 3, negative 4 and 2 I can change to 3I. You nak letak anak panah kat atas pun boleh. Minus 4J plus 2K. Bahagi dengan the magnitude. Magnitude ni 3 kuasa 2 plus negative 4 squared plus 2 squared. So 3i minus 4j plus 2k over divide by 3 squared is 9, negative 4 squared is 16, 2 squared is 4. So here is 3i minus 4j plus 2k divide by 9 plus 16 plus 4 will become 29. So the unit vector will become 3 over square root of 29. I separate into 3 parts. Minus 4 over square root of 29. And then plus 2 over square root of 29k. Pecahkan jadi 3 bahagian saja. So this is how we find the unit vector. The vector itself divide by the magnitude. Dia punya vector tu bahagi dengan magnitude of the vector. So kita kena cari magnitude of the vector lah. And the last part of for the today video will be direction cosine and direction angle. Ini adalah yang last untuk this video. Direction cosine and direction. So direction cosine and direction angle. So direction cosine. Wait, So direction cosine and direction angle. So direction cosine of a vector are the cosine of the angle between the vector and the three coordinate x-axis, y-axis and z-axis. So ini adalah dia punya angle lah, sudut di antara vektor tersebut dengan the coordinate axis. Dia punya sudut antara vektor tersebut dengan paksi x, paksi y dan paksi z. Let's say if P is equal to vector P is AI plus BJ plus CK, or the coordinate is A, B, or C, A, B, and C. Then the direction cosine are cos alpha, beta, gamma. Ini simbol saja. Cos alpha, cos beta, cos gamma adalah coordinate of A divided by the magnitude. Beta is coordinate of B divided by the magnitude. Alpha, gamma is coordinate of C divided by the magnitude. Jika nak cari sudut dia, direction angle of alpha, beta and gamma, kita cuma pindahkan cos ke sana lah. Bila pindah ke sana, dia akan jadi cos inverse. Cos inverse and cos inverse. So nak cari direction angle, kita kena cari direction cosine dulu. Nanti inversekan dia, kita akan dapat angle. For example, this one you can refer to like, let's say, given vector A is 2i minus 3j plus k. Find the direction cosine of A. So how are we going to find? So let's say vector A is 2i minus 3j plus k. Or I can write in the form of 2, negative 3, and 1. So for direction cosine, maksudnya kita ada 3. Satu adalah cos alpha, cos beta, and cos gamma. Setiap kali dia ada 3. So for cos alpha adalah sama dengan 2. Yang pertama ni, inilah kita yang first one. This is A, this is B, this is C. So means that 2 over magnitude of 3, this one, this vector, square root of 2 squared plus negative 3 squared plus 1 squared. So this one will become 2 over, kat sini kita dapat square root of 14. Cos beta is equal to negative 3 over square root of, sekali lagi, 14. Sebab kita dah kira dah. And then cos gamma is 1 over square root of 14. Kita calculate sekali saja. Yang lain sama. You can look at this one. Sama saja. Yang ni kita panggil sebagai direction cosine. If you want to find the angle, this is direction angle. Nak cari angle senang saja. So alpha cari yang pertama is equal to cos inverse dalam kurungan 2 over square root of 14. You can use your calculator. Macam mana nak guna calculator? So first you tekan shift and then cos. Shift cos and then put a bracket, letak kurungan 2 per square root of 14. So the first is 57.69 degree. I round off. Beta cos inverse. Beta 1 over negative 3 over square root of 14. So sekali lagi tekan calculator, shift cos in the bracket negative 3 per punca 14. So this is 143.30. And finally, gamma is cos inverse. This is gamma. 1 over square root of 14. By using your calculator, again, shift cos 1 dalam kurungan 1 over square root of 14. So this one is 74 point, when I round off, 50. So here is the direction cosine and direction angle. So this is a class for today. So is how we are going to find the direction cosine and direction angle. So lepas tu you boleh buat you can answer the exercise.